Hello guys, my name is Siddharth Mehta. I am your Udemy instructor for this course AWS RDS Databases. As this is the first chapter in our course, let us start with my introduction. To tell you something about myself, my name is Siddharth Mehta. I also go by the name Sid. By profession, I am an enterprise cloud architect. Some points about me. I have almost 2 decades of career experience in this industry, have been working globally with multinational clients and working mostly on solutioning and architecting on cloud and data related solutions. I have experience of working on all the major clouds, AWS, Azure and GCP. I am a published author, have authored hundreds of articles, white papers, co-authored and reviewed books, and I also author for some very reputed companies like Microsoft. I have authored a white paper for them on the MSDN library. So you will find me on the web. I am also an experienced Udemy author. This is actually my 11th course on Udemy, and you can see the previous 3 courses at the bottom. One of them came out very new. So I teach heavily on Udemy as well, and you will find a lot of my data courses. The only thing that I want to emphasize is I bring a lot of industry experience, and from that I am very passionate about teaching also to my colleagues, to my architects, my students, everyone. So with this guys, I just want to wind up my introduction. I want to keep it short. I hope that this brings that assurance in your mind that I am not some hobbyist who has just turned up on Udemy to make a course. I bring all that experience, and with that experience I teach very passionately to all my students, and that is what we are going to do in this course as well. So with this, winding up my introduction guys, once you are ready, can you please join me in the next chapter? Hello guys, welcome back. In this chapter, I would like to tell you something about the course itself and how RDS fits, what I have done here in this course, so that you understand that what these chapters are going to look like and why they look like this. So the first thing is, look at this diagram. This is the overall AWS data architecture landscape. I have another course called Data Architect Bootcamp, you would have seen in my intro, so I am borrowing some material from there. In fact, most of the chapters that are in this course are a nano slice of the same course. So in this overall scheme of things, this is where RDS fits. So RDS is not the only solution in the AWS data architecture world. I want to emphasize that there are a lot of different services for ingestion, migration, for data APIs, and let's say backups, analysis, EMR, big data, machine learning, etc. RDS is one tiny slice of it, but it's a very important slice because let's say you come from a traditional background or an on-premise background, or maybe you also come from an AWS application background and you are new. The first very logical thing that you would generally tend to do is spin up a similar database. Let's say you worked on Oracle or SQL Server in traditional environments. You would want to create a similar database on cloud, and that is where you will need some help, that how to get started. Some concepts may be new, and that is where this course will help you. So this is what we are trying to cover, and do not get into an impression that this is the only database thing out there in AWS. There are a number of things. Please keep one thing in view guys, that as I am making a tiny part of my Data Architect Bootcamp course for free in the form of this course, when you go through the chapters, at the start of the chapters you will see logos of my course or maybe references to some sections of my course. Please do not get confused with that, because I have literally took the original chapters. I did not wanted to trim out important details from this course and put it here in a free course. I am bringing the same value, exact same content that I put into my overall larger course in this free course, because I feel that all my data students who are part of AWS, or all my future potential students who are interested in AWS data related services, they should get the exact same value or exact same content that I teach in my original premium courses. This course is free does not mean that I am compromising the detail or the content. That is the reason the exact same chapters, even the logos have not been changed in those chapters. So those exact chapters are being brought over here. So that will be one thing that you may want to keep in mind guys while going through the curriculum. This is a tabular view of what I generally cover in my bootcamp course. So this gives you more idea. Relational Database Service is composed of 6 different databases. But for this fast track training, we will cover 3 of them, and still you will get the full coverage. I will explain you how. So these are the 3 that we plan to cover. MariaDB is actually an open fork of MySQL, means it's very similar. It has the same base as MySQL. Often there are comparisons of what are the minor differences between MariaDB and MySQL. So by learning this, you will cover a great deal there. PostgreSQL. Aurora is actually implemented in the form of MySQL or PostgreSQL. You can select any flavor for implementing Aurora. The storage architecture and all that is different. But by covering this, you will understand those kind of concepts also over here. And finally, one commercial database I wanted to cover. So I chose Oracle, so that you understand that in commercial database, when you work with this compared to other open source databases like MariaDB or PostgreSQL, how does it differ? So we will cover these three. Now what we will cover in these three? We are going to cover firstly some theory, some basic features, how to estimate the cost, because you are on cloud and cost estimation is very necessary for yourself, even if you are doing some personal development, even in case if you are doing it as a part of your project. And then at the end of the curriculum, we will have some basic FAQs answered. In MariaDB, we are going to cover all this. In PostgreSQL, all this stuff. And finally, in Oracle, it is just an overlap of what we have covered earlier, but you will see subtle differences, like let's say the licensing model and all. So we will go through a very simple exercise of standing up an Oracle instance, installing client tools. We will install client tools everywhere, like in PostgreSQL we will use PgAdmin, in MariaDB, HeidiSQL, Oracle SQL Developer. And from your local machine, you will be able to connect this instance, start working with it and fire commands. This course will get you up to speed where in under 3 hours, you will be able to set up all this. You will learn to set up all this stuff and start working as you would work on a normal on-premise version of relational database. That is the objective of this course. So guys, I have said enough in this chapter already, and you must be curious to get along with the course itself. So let me wind this chapter over here, and once you are ready, please join me in the next chapter. Hello guys, welcome back. Let me take a minute to tell you about the prerequisites. So there are not a lot of prerequisites. All you need to have is firstly a computer with admin access. You need to have internet connectivity because you need to be able to connect to AWS console in the cloud. You would need an AWS account to practice the labs. If you do not have an AWS account at all, or you are brand new to AWS, you may want to learn something, because to get started with RDS, you will need some basic fundamentals. And then sub labs may cost a few dollars, depends on what kind of configuration you use. If you are brand new and you are using a free tier, you may have some free labs. But in case if you are trying to use, let's say, an enterprise version of a database, it may cost some dollars. Basic working knowledge of AWS, like how to use AWS console or S3 or EC2 or VPC, or some basic concepts regarding networking are required, because without any AWS fundamentals, you may struggle a bit around the networking concepts. Being a database professional, you will still understand what I am doing, but when it comes to questions like, for example, I will select a VPC. Now you may think, what is a VPC? Those kind of questions, those kind of basics are not covered in this course. It is assumed that you know some very basic fundamental networking of AWS, which any AWS professional would generally know. So that is another prerequisite for this course. And finally, you need to have some conceptual knowledge of database world, like what is a table, what is an index, what is a backup, etc. So I am not starting from that a table is like rows and columns and all that. It is assumed that you have that kind of experience. Try to keep in mind, guys, that this is a fast track training. For me to teach you AWS RDS to an extent that you can get up to speed and start working on your own independently under 3 hours, for that, you need to have some fundamentals, and that is the reason for this prerequisite. So let me wind up this chapter over here, guys. This is only what I wanted to say about prerequisites. So once you are ready, please join me now in the next chapter. Hello guys, welcome back. Now let's start with the use cases. This diagram should be read in this way. If you have a database on premise, basically everything is done by you. This is all optimization, HA, DR, all the patching, maintenance, monitoring, all the facilities of the hardware like power and network and etc. If it is on EC2, AWS takes care of the hardware and the related items, and you do the rest. And if the database is on RDS, The only thing an end user is required to do is optimization. Rest of the scaling, HA, DR, backups, patches, etc. It is just a matter of configuration and AWS takes care of it. So that way the burden on the end user to do all these different tasks related to maintaining a database, that can be done away. So that is the biggest benefit of hosting a database on cloud. Here is the introduction slide. Amazon RDS comes in all the 6 different database engines. This is a marketing slide, so you will see all this: easy to administer, available and durable, highly scalable, fast and secure. And we are going to look at that. Easy to administer because you just need to do configuration options. In the previous slide you saw that you do not need to do all the different tasks that you generally do if your database is hosted on premise. So that way it's easy. Available and durable. You have multi-AZ deployment, replication, snapshots, failovers, backups, etc. We are going to go into a lot of detail and I will show you very soon. Highly scalable. The compute and storage, with a few clicks you can add a lot of capacity for the scalability. And fast and secure, you have SSD storage, and then there is provisioned IOPS for faster processing of the data disk, and data encryption is also available at rest and in transit for security. So that is all for the introduction, guys. We are going to cover more theory in the next chapter. I wanted to keep this concise and brief. I do not want to bore you to death with a lot of theory upfront in the initial chapter. You already know which databases we are going to cover, which are PostgreSQL, MariaDB and Oracle, and we discussed earlier how that will in a way cover the rest also. So for now, let us wind this chapter, and once you are ready, please join me in the next chapter. Hello guys, welcome back. Firstly, it gets deployed very fast just via 4 steps on the web console. So you go to the dashboard, you select database, configure basic properties, advanced properties, network, and that's it. And then you are done. Then people may have questions who are new to RDS, how secure it is. Lot of compliance is available. KMS, key management services for encryption. Every database has a firewall, so using security groups and the basic AWS networking, you can block all the traffic that you want. And using a combination of private subnet and a VPN to your corporate network, you can set up a dedicated connectivity and isolated connectivity just between your corporate data center and the instance that you set up on your AWS account. And let's say you may have questions that your database size is very large, tens of terabytes, and you need very high performance. So you can allocate up to 3 TB. This is just an example that you can allocate up to 3 terabytes with this. 1 terabyte for MySQL. This is for per database instance. And up to 30,000 IOPS for MySQL, Postgres, Oracle, etc. So this is the limit per database, and you can have multiple databases, probably 40 by default, and you can even increase that with a request to AWS. So lot of capacity in summary is available to you. High availability multi-AZ deployments. So we are starting with some key features. Firstly, just look at this diagram. All the traffic that may be there on the internet. Finally, you hit Route 53 or something, and then there may be an application or a load balancer. Load balancer will go to web servers. Web server will figure out the traffic may go from load balancer to any of the web servers. From there, the web server will make a call to application server. And finally, let's say what happens is it connects to the database instance. Now, due to some reason, let's say the database instance failed, or the connectivity is lost, or it is not able to boot up, or something wrong happened and it is unavailable. So what will happen? You will not be able, your application will crash. So in that case, what you may have to do is the same database instance may have to be set up into a different region altogether. That is multi-AZ deployment. One availability zone and another availability zone. So multi-availability zone deployment. Now the benefit of this is that, let's say if this instance fails in case of a multi-AZ deployment, the system would automatically fall back to the another one which is available and make it the primary. And then it will start creating a new standby. In the earlier instance, before this failure happened, this was the primary and this was the standby. And because of failure, now this switches back. And this is transparent to you. Just see this automatic failover, synchronous replication. So this is replicated synchronously, and you do not have to do a bit to set up this replication. This is done behind the scenes automatically. And this is inexpensive, enabled with one click, which means You just need to check a box in the wizard when you are setting up this instance. Just one configuration option, multi-easy yes or no. So that easy it becomes. So this is one of the benefit, one of the key features. Read replicas. We spoke of read replicas earlier. We are going to cover it into the Postgres. We are going to start with that, and we are going to work a lot with read replicas actually. Same diagram. What happens is, let's say that you have BI or reporting servers which just needs to read. Your OLAP applications may just need to read the data and then crunch it somewhere else. So there are a lot of different systems, maybe downstream systems, which needs to read the data. So what happens is, from a primary database instance, a replication is set up on a secondary database instance. This replication is asynchronous. So if you expect that at every millisecond the data will be exactly perfect, it may not be the case. The lag will not be in minutes and hours. It may be couple of milliseconds or at worst seconds, but I do not expect it to be really minutes and hours, lots of minutes. So this asynchronous replication happens, and this read replica is an exact cloned copy of this primary, and all your reporting applications can read this. Now this is also transparent. You do not need to set up this replication and all. You just need to say how many read replicas you want. You will get endpoints, and your BI or reporting server or any downstream applications can read from here. Relieves the pressure from the master node. You do not need to put a lot of capacity here for all your downstream, because if this was a single node, let's say serving 10 applications, you have to have a very fat, very compute intensive and very disk IO intensive instance. But this kind of read replication you can do with medium or moderate sized instances with regular capacities and still get that kind of scalability and isolation. And also, once if you need that, okay, now this read replica, you need to make this as a primary instance, because a lot of your applications are reading, and this is all now in a good shape to be considered as a master node where it can read and also write data. You can promote it and make it primary like this, an independent primary like that. So this is another key feature. Cross-region read replicas for enhanced data locality, even more ease of migration. So here is your master, and let's say you want to create a read replica into a different region altogether, you can do that as well. So that, let's say your master is in EU and you want to create a read replica in North America where your users are using it for different requirements, you can create that kind of read replicas as well. How the backups work. Automated backups and manual snapshots, two kind of backups. Because you have data, obviously now the question is that you have got scalability, you have got isolation. Now you want data security, data backups, because no one wants to lose data, obviously. Backups are taken automatically. You can restore to point in time. Maximum retention period of automated backups is 35 days. After that, it will start overwriting the backup. And manual snapshots means you initiate the backup, you take it yourself, and then you persist them until you delete them. You also pay for that. Backup stored in S3, and you can create new database instance from those backups. So in this way, the backups are divided into automated and manual, and we are going to have a lot of coverage on this as well. This is another detail of automated backups. Schedule daily volume backup of entire instance. You can archive database change logs, 35-day retention maximum, minimal impact on performance during backups, and taken from a standby when running multi-AZ. And it is taken from the standby when running multi-AZ. So if you have a multi-AZ deployment, there is synchronous replication happening in multiple zones. So whichever is the standby instance, that is being used for backups. So the performance of your primary instance is not affected. And in Aurora, it is a different game altogether. It has a different type storage, a cluster-based storage. So we are going to look at more details when we reach there. The snapshots, here it shows that how only incremental data is being snapshot. Always incremental, as you can see. S3 durability, the encryption is also inherited and copy across accounts, across regions. So all the backups that you take, you can copy those backups across different accounts also. So for example, if you have dev, test, stage, prod, you can take a backup in dev and maybe put it into stage, or other way you can take a backup from prod and put it into stage. So that way you can have your same data moved around different environments, and those different environments can be different accounts as well. Security and compliance. You can isolate all your databases via VPC. Security groups allows only specific ports to be operated. IAM based resource level permissions. So per user kind of policy also you can apply. Encryption at rest using KMS or Microsoft or Oracle TDE, transparent data encryption. This is a built-in feature of SQL Server or Oracle. And SSL protection for data in transit. So the connection between your client and your database instance is encrypted via SSL. That is also possible. Security groups, the same concept, that you can allow specific IPs or specific security groups to access to your database instance. IAM policies, so as you can see over here, that you can allow create database instance only for someone, and you can say that these are the resources, for example, DB test, OG default, PG default, subgroup default, etc. So for all these resources, you want to allow create database instance. That kind of configuration can also be done. Encryption, master keys, data keys. So you can have two-tiered key hierarchy using envelope encryption. For those who are new to encryption, they may have to Google around a bit about what is this envelope encryption. But simple part is you have unique data key that encrypts customer data using KMS master keys available for all RDS engines. Master key is common, customer specific data key, so that let's say if this is customer 1 or group 1 and group 2 and 3, you have specific keys for that kind of databases. What are the benefits? It limits the risk of compromised data key because just using one key it will not work. Better performance for encrypting large data, easier to manage, centralized access and auditing of key activity. So using KMS, this is the native benefit of KMS that you get over RDS. So guys, we went through some of the basic key features of RDS in pretty good speed, I guess. So with this, we are going to wind it up. We are going to have a lot of coverage of RDS. So even if you did not catch it now, when you do the labs, you will get it. So for now, we will wind up this chapter. And once you are ready, please join me in the pricing chapter. Hello guys, welcome back. Let's get started with pricing now. Generally in rest of the AWS services, we touch pricing very mildly so that you understand how the pricing works. Here we are going to look at a lot of aspects of pricing. The reason is most of the services may or may not be permanent in your solution because you may scale it up, scale it down, or even remove it, create it dynamically. Databases are one such services where generally you store it permanently. Most of them, at least the relational databases and those sorts of databases, and you have the data available 24/7 for your services. So this will really create a lot of cost. Plus it keeps on growing. So the cost actually will keep on growing according to the trend of the growth of data in your solution or databases. So here this plays a very important part. And as an architect, everyone will bank upon you to tell them what should be the right model because it will directly impact pricing. So you should clearly know what affects the pricing of the databases, typically on RDS. So I will explain to you how to understand this and how to work through the calculator so that you know when you do this job. Firstly, there are different types of database instance. This is not an exhaustive list, but most of them are R5, 4s, T2s, different purpose, different types of vCPU, RAM, the EBS optimized bandwidth and network bandwidth. So this is the IOPS actually. So this should give you an idea of what type of instance you are choosing will mean how much of capacity you have, how much of RAM, how much of vCPU. So firstly, if you do not know this, whenever you start with the pricing exercise, know which instance you are picking up. What may be the right instance for you based on your needs. After that, how RDS billing works. Firstly, you have a size of the instance. For example, M3.extra large. That would mean certain amount of vCPU and RAM. After that, you will have a database engine in a region. And then you will have single AZ deployment or multi-AZ deployment. And finally, you have on-demand instances or reserved instances. So based on that, the cost will come like this. 720 hours means 30 days full-time 100% utilized bandwidth. After that, size of the database, which means here it is 100 GB. So size of the database into the cost. Here it is the compute time. So the size of the instance, this is the cost into how many days. Plus, if you have any provisioned IOPS, for example, here it says 100 GB instance with provisioned IOPS, then here are the provisioned IOPS. 1000 IOPS means that also will have a cost. So all this multiplied by 30 days, and here is the cost coming out. Let's look at it into more detail. So simple monthly calculator, just go over there to the AWS simple monthly calculator. Amazon RDS, come over here. When you come over here, it will give you all the different options to add details. And as and when you add detail, you will be able to see the monthly bill. So now let's go over it one by one and look at different aspects. So first click over here and add this detail. So what I have done is give some description. Let's say I am saying dev instance, one database instance, 100% utilized for the entire month. So 720 hours. Typically, you may have plus or minus more. Database engine and license, I am starting with MariaDB. And class of deployment, this is the size of the instance and single AZ or multi-AZ. So I have selected, just for an example, R3.2x large and single availability zone, general purpose storage, 20 gigabytes and no provisioned IOPS, all default, no backups, nothing else. So the cost is coming out to be, the monthly bill is coming out to be $691.74. Now let's do one thing. Let's add a standard backup of 20 gigabytes, because if I have this much data storage, I am expecting that I may take a backup up to 20. It would be more, but let's start with 20. Standard backup of 20 gigabytes. So that marginally increased the cost, as you can see over here. Now I feel that there may be incremental backups, so let me make it 40 from 20. So when I make it, you will see that the estimated monthly bill is $692, still not moving a lot. So let's go and add more data transfer in and data transfer out of the database instance over the network. Still, the cost did not change much. So let's add more data transfer intra-region from one region to another. Let's say you have data in one region that is getting pumped into the database instance in another region. So let's add that 40 as well. Make everything 40. Still, the cost did not change much. So as you can imagine, the first thing that is highly impacting is the size of the instance. Now if you go and see the actual split of the cost, as you can see, the database instance, the cost itself is this much, and rest of them is delta, and that also amounts to $5 or $6 at max monthly. So that cost is not coming out much. This is the first lesson to learn here. Second thing, go back and over here. Now instead of using on-demand instances, I took out everything and I placed into reserved instances. Now reserved instances can be, the payment can be of three types, and it can be 1 year or 3 year terms. So for example, I have selected the same set of details but 1 year term and no upfront cost. So I pay whenever the bill comes. That is the kind of payment, no upfront. So the cost is coming out to be $442 monthly, much lesser than the $691. After that, let's say if I change the mode of payment and I say that partially I will pay upfront and then partially I will keep on paying as the bill comes, the cost still decreases from 400 plus to around 300. And if I pay full upfront for 1 year contract, I pay all the cost for 1 year upfront. In that case, all upfront, you will see $104 monthly. So that means it's very cheap, right? It's barely $1,200 or something. So let's go and check it out. It's $4,736. It's not $1,200 or $1,500 based on $100 monthly calculation. The reason? You are paying for the reserved instance one-time fee upfront. So overall it is much lesser, but you are paying all of this upfront. And from there, you see that the monthly cost, the rest of the cost, as you see for the support and all, that is being shown over here. So based on that kind of split and whatever is the balance that you have to pay, that balance, that mix comes out to be $104. So in summary, let's say that you had like $700. So 12 into 7, 84. So that earlier cost was $8,400 per year. And here it is not $8,400, but it is $4,736 plus $100 per month. So add $1,200 to that. So it's around $7,000 still. And there it was $8,400 plus dollars. So it's a marginal difference that you get around 20-30%, but it's not a great difference that you will get. Like let's say this is $1,200 and that was $8,000 plus dollars. So you should understand it clearly that the moment you see that the monthly was $691 and the moment you see here the monthly is $104, that means that you are getting, let's say, 6 times less. That is not the case. That is the reason to understand pricing clearly. So let's move forward. Go back to services. Now what I am doing is change this to multi-AZ. Not single AZ, make it multi-AZ. So as you can see, the cost did not budge a lot. It is just 108.47. But as we learned that we need to look into the details to understand how this figure has arrived. So come over here. You see the cost is 108, that is right. But your one-time payment shooted up almost double. As you can see, 9572.05. So what happens is, whatever cost that you are paying for one instance, you are paying the same cost now for 2 instances because this is multi-AZ. So in that way, your cost has increased. So your one-time cost is around $9,572. And then over the top of that, you pay around $100 every month. Now this is the support pricing. You can remove here and there, whatever it may be based on your plans. But that is how the monthly cost is 108. Your upfront is totally double. So pay attention that way for multi-AZ. Come back. Now again going back to the on-demand instances, select the same set of details. And for example, I am selecting SQL Server Enterprise Edition. Now we are going to different database engines, legacy. So bring your own license if you have the license and select that, and 20 GB and all. You will see the monthly cost coming out to be 977. This is on demand, so there is no upfront cost at all. Now what you can do is make it multi-AZ, and you will see that your monthly bill will shoot up to 9151.15. So that's how much the cost can go up with multi-AZ deployment. Change this to 200 GB and select Enterprise Edition license included. The cost is $8,000. So now what I'm going to do is I'm going to just keep on changing engines. You keep paying attention at the cost, the monthly cost, how it changes. And whenever the database of your choice comes up, you may want to take a look at it, or you can also practice it at your end. This tool is freely available for you. So this is the cost. Now let me change it to Express, which is the smallest edition, and then you have a restriction of instances you can choose. So the moment you choose this, you will get m1.small only. And with 200 GB also, the cost is pretty less because it has a restriction of maximum 10 GB of database size. So going with standard edition, the cost is 4918, and then going with web edition, the cost is 1476. So in this way, depending upon your edition, because this license imposes restrictions on the type of use, your cost will change. And then Oracle BYOL, the cost is 1500. License included 2985. License included again SE2 3205. So this is the varying nature of the cost. This is actually multi-AZ. So PostgreSQL much cheaper than Oracle, 1657. MySQL is 1576. Aurora. Now, Aurora has a different mechanism. It has the database instance size because this is a native instance, but it also charges extra for your IO rate or number of change records per hour, target backtrack, etc. So here you see it's 871. Now I am changing the number of records and target backtrack window. So as you can see, I made 1 million records change per hour and backtrack up to 72 hours. That's how much I want to go to backtrack, like roll back up till this many hours. So the cost did not change much. As you can see, if you go back, you will see that still the database instance is the biggest reason for the cost, and rest is all marginal. Backtrack feature is 63, something significant to consider, but still not much. Go back, and over here I am adding a rate of 1 million requests changed, but still nothing much, still marginal. Now here you can also change the type for Aurora. Here I have MySQL compatible. I can change it to Postgres compatible and change the size of the instance, because when I choose Postgres, only certain instance sizes are available in Aurora. So select any one of the size and you will see. And also another thing to notice, Aurora supports some fixed size of class and deployments. As you can see here, I have selected Aurora PostgreSQL compatible, and here in the class and deployment you will find only 6 different types of class and deployment, that is the instance sizes. So that is something to take care of. Depending upon which database engine and edition you select, like SQL Express or Aurora, you will get a fixed size of class and deployments, and that will impact your cost as well. So guys, I guess this much is enough to learn pricing about your database instances, and in the similar manner you should exercise a lot of caution and lot of attention to detail while working on the pricing of all these different AWS services that we cover. So with this, we will wind up the chapter over here guys, and after this we will look at few FAQs before jumping on to the labs. So let's wind up this chapter here guys, and I will see you now in the next chapter. Hello guys, welcome back. I just want to take a minute to tell you about the masking related information in the upcoming chapters. So you will see something like this. If you see this black box, some of the information you will see masked. The reason is it is very security specific, because this reveals your account, or at some points it reveals your VPC IDs, or it reveals your security routes. So those kind of information at times you will see masked. I have seen students at times complaining or even getting very upset that why this kind of information has been masked, or try to mask it in a different way, or maybe this black box is annoying. I admit that I need to do a better job at masking this information, but for now this is the convention I use to mask the information, so that you also can easily make out that when you are working with these kind of details, what information is very security sensitive, and you will also get a hint. So for example, whenever you are sharing this endpoint, this may reveal your account ID. So those kind of things, try to please bear with me wherever I am masking, and also try to keep in your mind that this is security specific. Even when you deal with your case, try to deal with this kind of information very carefully. So guys, that is one point I wanted to make before I start the actual chapters. That's all. Let's end this chapter and let's jump on to the next one. Hello guys, welcome back. So let's get started with the first lab in RDS. In this chapter we are going to set up MariaDB. As you can see, I have already logged on to the console, and the region that I have selected is Northern Virginia. I have some VPCs already in Northern Virginia, and when we create this database, one again new VPC will be created. This may not be convenient, and I want to demonstrate that, but we will see that when we will wrap up this chapter, when we will get away with the MariaDB instance, but that is at last. For now, we will get started with this in Northern Virginia. The point that I wanted to convey is, going forward in the rest of the chapters, I am going to use Oregon. I would suggest that you select a region which you can use like a playground, where you can create stuff, totally remove everything, and you will still be okay and not lose anything. The practice we would be following in the rest of the databases is, we will create a database and then we will delete the VPC at last. So all the stuff gets deleted. This is one easy way to remove everything. So firstly, let's open up RDS. Type RDS and you will be able to search it like this and select RDS. This will open up the RDS homepage. On the left hand side you can see a lot of different items over here. On this different items we do not need to focus for now. We are going to cover all of this one by one. When you click on create database, firstly check whether it is for the database that you intend or it is for some other database like Aurora over here. Scroll down. For now, ignore the rest of the details, just focus on this create database. The service dashboard shows that the health of Amazon RDS in Northern Virginia is operating normally. So we are good there. Click on create database button and you will be taken to the first option where you select the engines. Here there are 3 steps: select engine, specify the database details, configure advanced settings. We are going to see advanced settings in the next chapter. In this chapter we are going to cover till the database details specification. The first step is to select which database engine we want. MariaDB, MySQL and PostgreSQL are the open source databases. Aurora is an AWS Cloud native database, and Oracle and SQL Server are commercial database. We all know that. So we are going to start with the first one is MariaDB because I feel this is the simplest of all in my personal opinion. So let's select MariaDB. When you select that, you will see this 4 steps. You will see the limitations and different capacities that MariaDB supports. Scroll down, take a pause, read all this. For example, it supports 16 terabyte of database size and all those different details. Go through it. Now here it gives you an option whether you want to enable only those features which are eligible for free tier. If you select this, some of the features may be disabled during the configuration itself. So for now, I will not select this. For free tier, whether you are covered or not, you may want to check your quota and find out whether you are covered under free tier or this will incur some little expense provided you create it and immediately after you study it, you get done with this database and delete it. So for now, click on next. Here you have to choose which type of use case do we have, a dev or test kind of use case or a production use case. The only thing this options influences the default values it will provide you when you select the basic settings for the database details. For now, we will select dev or test, and after that, once we go to the next, we will see the different configuration options. But before that, let's go to the pricing and understand this in a little bit detail, because understanding this pricing, what influences the pricing, is a part of the configuration itself. So let's click on this. It will open up the pricing page. You can go either to the simple monthly calculator, which most architects use, or you can go on the MariaDB specific options. So let's see first the simple calculator. I have already pre-filled it that let's say we are trying to create a dev MariaDB instance, one database instance used 100% of the time, MariaDB, so no license or those kind of requirements. Other database do have different kind of licenses. And here I am using R3.2x large and 20 gig storage. And if you see, the cost is coming out to be $691 as a monthly bill. Now this is one way to see the pricing. Go to the MariaDB pricing page and over there you will see different pricing for the different instance types of databases for MariaDB. Before you start looking at this, make sure you are in the right region. So select this and go to Northern Virginia. Different regions can have different prices. Over here, if you see the R4.2x large cost almost $1 per hour. We can take a smaller size instance because for our exercises we do not need this, and even for a general dev environment you may not want to go with an R4.2x large. So let's go back and change this to M4.large. When you go this, you see that the price decreased to $128. Such drastic is the change and such big is the impact of the type of instance that you are trying to create. Now let's say we are going to use it only for a week and maybe let's say 40 hours only, and then we are not going to use it. Change the usage over here, and instead of 100% utilized, which is typically 720 hours, 24 hours into 30 days, instead of that we are going to say 40 hours. So when you change this to 40 hours per month, the bill reduces to $7. Such is the impact of the usage also. So if you are going to do this exercise and maybe spend 1 or 2 hours on this and then delete this database, it may cost you maybe $1 or $2 at max. So we are good there. Now let's go back, select the dev and test, and then click on next. Now we are going to select all the different options for this database. First is which particular type of license. There is only one available, which is the GPL. Database engine version, there may be multiple supported. If you have a specific one in mind that AWS RDS supports, you can select that, or you can go with the latest one, which is always selected by default. It gives you an option to select free tier. Then when you enable this, only free tier worth features are enabled, rest are disabled. For now, we will just wait for a moment and then check it. Scroll down and you will see that the database instance class R4.x large, 4 vCPU, 30 GB RAM. It's a fat machine. We do not need that much of it for now. But see the bill over here. The bill is coming to be $352.70. Now This is not 2x large, so do not confuse it with what we saw earlier in the pricing page. This is extra large. The next option is what is the new instance class that we can create, because this is a fat machine. For this exercise, you do not need anything more than a T2.micro, 1 vCPU, 1 gig of RAM. Select that. Multi-AZ deployment. Now this is an interesting option which deals with high availability. Click on info and you will see that what multi-AZ deployment is. It creates a replica in a different zone which is synchronously replicated from primary to the standby. Let's understand this in a little more detail. How do I ensure high database availability? This is a question that most architects would worry about. So multi-AZ deployment would mean that there will be standby in a different zone which is synchronously replicated, and in case of a failure, the connection is automatically routed to the standby which becomes the primary, and it will create a new standby afterwards. How does it take care of this automatically? The primary takes continuously data backups on EBS, and this is continuously replicated and synchronized with another standby. And there is a service in the background which takes care of monitoring whether the primary is up and healthy. In case if it detects that it is not healthy, it is not running, what it will do is it will just remap the address of the primary to the secondary, and all connections is routed there, and just with this DNS the failover is done, and also in the background a new standby will be created. So this is what is the impact of multi-AZ deployment just by selecting the option of yes or no. For now we do not need this, and this feature also costs, so we do not need this for now. Go back, let it be no. The another thing to check is the storage type, which is general purpose SSD or provisioned IOPS. If you need a lot of IO for your application and if you need a very high throughput storage, then you can go for IOPS, which again costs extra. For now we do not need it. We will go with the general purpose SSD. And then now once we are done, we can select this option. Only enable options eligible for RDS free usage tier. So when we check this, multi-AZ or storage types and all, that is not covered in it. So all this got disabled. Finally, we come to the settings part where we have to specify the database instance name and the ID and password with which we will connect to the instance. So fill up some details like this. I have given my MariaDB instance, AWS user is the ID, and then I have confirmed the password. So these are the basic settings that we are trying to configure. The advanced settings we are going to look at into the next chapter. But before that, let's quickly summarize what all we have configured so far. We configured first the database engine, which is MariaDB. We provided the license type, which is GPL. Instance type, we selected a T2.micro. Multi-AZ storage type and size, that are not important for us for now, but we understood what are those. Database instance name, my MariaDB instance is the name I gave to it, and then the user ID and password to connect to it. So this is the configuration we have completed so far. In the next chapter, we are going to look at the advanced settings. So go through these settings, understand it in more detail, read the AWS documentation if you are interested to understand this in further detail, and once you are ready, please join me in the next chapter. Hello guys, welcome back. Now we are ready to start the advanced configuration settings. Before we jump into the configuration settings on the console, a little bit of theory to understand how the networking is done, because the first thing that we will have to configure in the advanced configuration is networking. So here is a small diagram which shows you where the database is placed. Firstly, there is a boundary of VPC. Inside the VPC, there is an availability zone. Inside the availability zone, there is a security group, and within that, there is a database. So whenever a connection is made inbound or outbound to the database instance, it has to pass all these boundaries. And in order to set up the database, specifying right from VPC to till the security group is necessary. And in our configuration settings, the wizard will ask us. Some points to keep in mind is, what does VPC provide us? It places the instance in a private subnet, making it secure from public routes on the internet. So this subnet is private here. If you assign a public IP, that is the database instance IP firewall protection, lets you securely control network configuration. Turn off public accessibility in DB instance settings to restrict access to outside from Amazon VPC. So, in case if we want anyone to access the database instance outside the VPC, by outside the VPC mean, for example, let's say you have a editor which wants to connect to the database hosted on cloud. In that case, this is outside the VPC. If you do not turn on the public accessibility, that is the public IP address or the endpoint that gets generated, you will not be able to access it. We will see it very soon in the settings, but this is what it means. Databases are generally placed in private subnets, in production environments especially, so that no one from internet can directly hit the database. In case if someone wants to edit or check the database using those kind of editors hosted on local machines, then generally the idea is that VPN servers or VPN gateways are set up on the VPC and someone connects to those VPNs so that your local machine becomes an extended part of the VPC network, and by that way you can still connect to the database group and it creates a secure tunnel. If there are things like direct connect or those kind of things are already created, that are other options apart from the VPN connections. So these are some of the options you need to keep in mind. For now, we just need to understand what are the configuration that goes inside while creating the advanced configuration settings for our database. So we will keep it to a minimal, the networking part, because I do not want to bog you down with the networking details. But as an architect, it is necessary for you to understand what networking goes inside. So now let's jump on to the actual configurations. If you see over here on the advanced settings page, you can see the network and security part where it is asking us what is the VPC, subnet group, availability zone and security group. We will leave it up to the wizard to create a brand new VPC for us, brand new subnet group, brand new security group. It creates all the associations by itself and creates the ready network for us in which our database will come ready for us. Regarding public accessibility, yes or no? If we select no, then it will not create a public IP for us and there will not be an endpoint which can be reached over internet. This is the ideal scenario which you do generally in a production environment where you want to allow access to the database only from within the VPC. So app servers only can hit it, no one else can hit it. But in case of our scenario where we want to perform an exercise, we do not have any sensitive data or there is no security risk at all. So we will go with public accessibility, yes. So click on this and firstly see what is public accessibility. Once you see the public accessibility, you will understand that a static IP will not be created. For now we need it, so click on yes. If you do not select this, you will not be able to access the database using an editor installed on local machine, which is the topic of the next chapter. So please check this carefully. After the public accessibility is selected, let's move on to the database options. This is the database name. In the earlier settings, we created the instance name, which is the server. Now we are creating a database inside it. Here the port, parameter group and option group are specified. Parameter group is all the parameters that a database reads and configures the environment. Those kind of database related parameters, if you want to specify, you can specify in this. And option group is where you want to specify that it has to be cached, or if you want to set up some kind of encryption at rest or those kind of things, you can configure this. This is available over here for every type of database. For now, fill out the database name like this. I have given my personal DB, and also you can see what option group means. Option group enables any optional functionality. Now moving on, encryption. Here encryption is not enabled, firstly because the instance type does not support encryption, secondly it is because of the free tier. I started configuring a new database from scratch so that you can see that if free tier was not selected, how would this look. And if you see over here, I opened up a new tab over here, did all this, and you will see that enable or disable encryption is available because this is not free tier. So going back, scroll down and you will see the next options are the backup related option, which is an integral part of any database management system. So when do you want to take backup and how long do you want to retain it? There are two types of backups, automated and manual. We have a full chapter on backups and restores, so we will cover more there. But for now, these are the settings, like how long do you want to retain the automated backups and what is the window when you want to take the backups. And do you want to copy some tags when you are taking the backups? So those are the options available. To understand how backups are really taken for databases, here is a slide. There are two options, automated and manual snapshots. RDS backups leverage EBS snapshots stored in S3. So all the data is on EBS volumes and those are being backed up to the S3 buckets, which you cannot directly access for some of the databases. Transaction logs are stored every 5 minutes in S3 and supports point-in-time recovery also. No performance penalty. Whenever backups are being taken, there should not generally be any degradation in the performance just due to the backups. Of course, there can be little bit slowness here and there. It cannot be the 100% exactly the same in my practical experience, but generally you can expect that there will be no performance penalty. Snapshots can be copied across regions or shared with other accounts. For example, you are taking a backup in Northern Virginia and you want to create the same database, let's say in Sydney in Australia. So what you can do is you can just copy the snapshot to a cross region, and from there, using that snapshot, you can create the same database. And we are going to cover that in our backups related chapter here. So for now, just park that in your mind that it can be done in cross region also. So let's get going. After backups, the next options are monitoring. Do you want enhanced monitoring? If you generally do not open up enhanced monitoring in recommendations, you will see that it is missing, but which is fine for now. Enhanced monitoring is useful when you want to see different processes, threads, a lot more details in the monitoring part. For now, we are okay with regular monitoring, so disable enhanced monitoring. Log exports. In case if you have a need for audit log or error log, general log and slow query log. These are the four kind of logs generally available for all the databases. So whatever logs that you wish to see, you can switch it on and you will see it in the CloudWatch. You will have to give an IAM role for that, so that using that role, RDS will try to access CloudWatch and write log data into CloudWatch. For now, we are interested in just setting up the database. We are not going to go deep into the logging part for now. This is more for debugging and error collection. As an architect, you need to know what are the kind of logs available and from where can you configure it. So keep that in mind and let's move on to the next settings. The last setting is the maintenance related setting. So if you want the database to be upgraded automatically in minor versions or to major versions, and what can be the maintenance window, if you do not have a preference, it will do on its will. But if you have a preference, you can select the window that upgrade my database or maintain my database only during this time durations only. Let's say there is a green zone and in the night, let's say there is a 1 hour or 2 hour window when the users are not active, or let's say when no one is using the database and you want maintenance to be performed only during those times, you can specify the times over here. This is a very critical part, though it looks very trivial, but if you do not select the right maintenance settings, you may be using your users may be using the database at some point in time, and suddenly you will see that connections are getting failed or something is going down. That is because maintenance is in progress and you never specified when to do maintenance, or you just selected no preference and the maintenance happened. So make sure that the right window is selected. With this, we are done with all the settings over here to create the database. So now we are done with all the steps to create the database. Select no preference for now and then click on this button create database, which will create our database. As you can see, it is creating, and then you will soon see a message like this that your database instance is being created. So let it create. We are going to see what all happens during creation, what all are the different events and all those different type of things in the next chapter. For now, let's go back and quickly summarize what all we have configured in this chapter. We started with the configuration of firstly VPC, subnet, availability zone, security group. We left it up to the wizard to create all of these brand new and configure it for our new database. Public access, we chose yes because we want to access it from our local machine. Database name, port, parameter group, option group, we gave all the default values here. The database name we gave my personal DB. Encryption, we selected no. Backup, we selected whatever the default backups, so automated backups will be taken and it will be retained for 7 days. It keeps on taking backup and it keeps on replacing them. Then there will be monitoring. Monitoring options are no enhanced monitoring. Logs, there are 4 type of logs, but we have not chosen any logging for now. And then maintenance options, we have not given a preference. This is because we are going to just go over this database, understand it, and then delete this database so that it does not cost us. And because we are going to get rid of it, we did not take the pain of configuring everything like logs and maintenance windows, but we understood what the usage of these options are. So with this, we have completed all the configuration options to create the MariaDB database. Congratulations guys, your database creation is on the way and soon you will see the database getting created. So with this, we wind up this chapter over here, and once you are ready, please join me in the next chapter. Hello guys, welcome back. Now that we have created the instance already and it is being created, let's scroll through a different set of details that are available within the instance. It is yet being created, so all the details will not be available up front, but let's get started and see what is available and how it gets available step by step. So what you can do is click on the view database instance details like this, and you will be able to see that here is the instance that we created. Now the status, as you see over here, it is creating the database instance class is t2.micro, and then here are all the different CloudWatch metrics. You can go through all the different metrics one by one. There are 3 pages. You can scroll through here. You can also configure it from the settings. So firstly, let's scroll down and see what all metrics are available in the first page, just to get a stock of what all CloudWatch metrics are available. The CPU utilization, database connections. This is like an admin console where you can see all the different stuff. Freeable memory, free storage space, read-write IOPS. Keep scrolling and then you will reach the connect part. This is an important part where the endpoint will come. This endpoint is the actual server address that we will try to connect to. Because the database is still getting created, this is not available yet. It will be available soon. And as you can see over here, it is publicly accessible, which is what we need. The security group, rules and everything, because we have elected to create a new VPC and all the internal networking brand new. So it is yet getting created. So let it go on like that. Come down and you will come to details. This is the summary of all the configurations that we have done in the previous 2 chapters. Most of it is captured over here, and you will be able to see that, let's say multi-AZ is no, and the automated backups enabled 7 days. All the different items that we selected, the general public license, etc., all is available over here. You can go through all these details just to ensure that it is the same what we selected earlier. Scroll down. Replication, we have not set anything yet, so it's showing the same instance that we created. CloudWatch alarms, you can create an alarm from here. If you want a snapshot, you can create a snapshot from here as well. We are having a full chapter on snapshots like backups and restores. So for now, we can park it. And if you want to add any tags, you can add a tag as well. So now let's go back, scroll down, and you will be able to see logs and events. So if there are any logs, if we had selected those 4 type of logs, that would get captured and you would have some of the logs created here. And any recent events, because we just started it, there are no events as such. Now go back on the top, scroll up, and you will be able to see the instance actions if you click on the instance menu. So when you click on this menu, all these different options are available. We are going to look at most of these. The read replica and promote read replica, I have reserved it to do it with a different database. So because we are starting, I am not including it here, but we have it covered in a different chapter. So right now the status is creating. Wait for some time and it will change to backing up. This is a set of events that takes place before your database is made available. Whenever the database is getting created, it creates a backup on the spot at the same time, so that you have one backup available of a clean snapshot, and then you can keep on changing your stuff so that if you want to revert back, you have that backup available. So that is one thing. If you go out at the instances and you click there, over there also you will be able to see that it is backing up. Now you can scroll here and then you will be able to see that what is the instance size, the VPC, multi-AZ and all that stuff. Let's go back. Now click on the subnet groups and you will be able to see what all subnets are there, what all parameter groups are there. All the parameter groups are listed. This is the MariaDB parameter group that we are using. Options group, you will be able to see all the different option groups available. Click on events. These are the events that have occurred so far. Database instance restarted, created, then backup is being taken, and now it is creating an automated snapshot. Go to subscriptions. We have none, but you can subscribe to certain events and arrange some CloudWatch alarms, Lambda and all those kind of things. And recommendations, there are no recommendations as such. Things are fine for now. So that is a good thing. Go back to instances. And over here you will be able to see that there are VPCs. So there is one VPC that has got created. There are different subnets and everything. So this is a good way to jump onto the networking part of your database. So let's say if you want to arrange certain IPs access on some security groups, so you may want to go to the VPC, go to that security group and everything. So you can jump onto those kind of stuff right from here. For example, if you want to go to the VPC, click on this VPC and it will open the VPC console, exactly the VPC that is being used. So that is one good shortcut to keep in mind, because you may often want to configure your network here and there for certain IP access or for certain security groups, etc. So go back, and by now, as you can see, our database is available. The status is available over here. If you open the instance, there also you will see the status is available. So now that the database is available, we should have the endpoint also available. So scroll down for that and you will see that in the connect section, the endpoint is available. This URL is the server instance address that you can use to connect to this server. Also in the security group, you will see that the IPs have got added, your IP /32. That means the one single IP has got added for inbound connectivity, where from your machine you can make a connection, and the outbound connectivity to the internet, which is this address, is already available. If you want to add more machine IPs, for example, you have got some friends or team members or someone to whom you want them to allow access to access this database instance from their own machine, then you can go to the security group, add a inbound rule with one more IP, and that IP /32, which is the CIDR block for one IP address. Add that rule and you should be able to provision that access to the required IP address. So take a note of this endpoint. You can always come back and copy this endpoint from here, but it's good to keep it handy so that in the next chapter, when we are going to access it from the local machine using an editor, you will need this address from there, so you can paste it there. So this is the endpoint address. Now let's go to parameter groups. When you go to the parameter groups, you will be able to see that there are a lot of different parameters. What I would suggest is type storage. When you type storage, you will find the storage related parameters. Initially we heard that there are different, in one of the initial chapters we learned that there are different storage engines supported here, and as you can see over here, all these are the allowed values which are supported, but the one that is used right now in MariaDB is InnoDB, because there are some certain features which are supported only if you use InnoDB as the storage engine. So this is one particular feature of MariaDB to keep in view. So with this, we are done with creation of the database, and we have got the endpoint that we can now use to connect to the database and log in and do some activity on the database. So let's wind this chapter over here. Try this out, guys, and once your database is available, you have collected the endpoint, please join me in the next chapter whenever you are ready. Hello guys, welcome back. We are on the easiest part of setting up the MariaDB instance. We have already set up the instance, but now one thing remaining is trying to connect to it using any local query editor tool of choice. HeidiSQL is one of the tools that we can use to connect to MariaDB. So here is the URL. You can connect to this URL, go on the downloads and install it on your local machine. The compatibility note says that it supports Windows XP, Vista and up to 10. Luckily I have Windows, so should work fine. For Mac users, I am not sure which editor would work fine. I'll try to figure it out, but this is also suggested in the AWS documentation that we can try it out, so I'm going to use this one. Assuming that you have installed it and downloaded it on your machine, you will be able to see a screen like this once the download has been done and installation is completed. So the session manager will open. When you see the session manager, it will have this kind of window and it will give you an option to create a new session. So click on new. When you click on new, you will need the endpoint here that I was mentioning earlier. So here, these are the actual settings that you should do. Network type should be MySQL TCP/IP because it's a MySQL compatible and it can connect on TCP/IP. Hostname should be the endpoint, the connect endpoint that we created, that we got after creating the instance. Copy and paste that endpoint over here. Do not mention any ports or anything, just the endpoint. After that, provide the user ID and password that we provided while creating the database. Port should be 3306, which is the default port. And after this is done, simply click on open. If everything is right, this should get connected within seconds. And you should be able to see a screen like this. Now as you can see, there is an InnoDB database by default, information schema, and there is the database that we asked for, which is my personal DB. Click on this and you will be able to see all these kind of things popping up and it would get connected to your my personal DB database. So this was the entire intention to create the database so that we can connect to it, and now you can deploy all your different stuff, create tables, views and all those database objects that you need. So this was all about connecting to the database that we created using HeidiSQL tool. With this, we will wind up this chapter over here, and in the next chapter, we will go back to the console and learn more about backups. So whenever you are ready, please join me in the next chapter. Hello guys, welcome back. In this chapter, we are going to learn about backups and snapshots. Now here is the first slide which shows what is the difference between automated backups and manual snapshots and when to use them. The automated backups, they have a retention period of 7 days by default. You can keep it maximum for 35 days. It supports point-in-time recovery and it's good for disaster recovery. Manual snapshots, on the other hand, those are created manually either directly on the console or programmatically. You can keep them forever until you delete them. It restores to the saved snapshot. So whatever snapshot that you took of a current state or whatever that point in time state of that database, you will restore it to that particular point, and you can use that for checkpointing. Like for example, if you want to label something or if you want to version something, that this is the state of the database, let's say it is version 0.5, and now what you will do is you will take a snapshot and then let the other changes go on, and if something goes wrong on the next set of changes, you can always revert back the same 0.5 database from the snapshot that you took. So this is the difference between automated backups and manual snapshots, and the uses are a little different. So this was the theory that you need to know before going into the backups. So now let's get started with the backups part of it. What we will do is, the automated backups are already getting created and we saw how the configuration is done while we set up the database. We will focus more on the manual snapshot creation process. So let's get started there. I need you to firstly go on the console and go to the snapshots part. You would already have one snapshot. If you would have observed carefully during the events, there was a backing up process and that was creating a snapshot. So the snapshot is already there. This is an automated snapshot created. From this automated snapshot, let's try to create a manual snapshot. So what you should try to firstly do is firstly reach here and see the snapshot. Next, scroll over here so that you can see the details. It is available. Here are the VPC, what is the type, what is the storage size, then whether it's encrypted and zone and all those different details. So now come back, select this and open it. When you open it, you will be able to see that all the different details at a more detailed level. In that scroll, you will see limited details. Over here, you will be able to see all the details. Scroll down and you will be able to see what KMS ID, if at all it is encrypted and such kind of details. Scroll down, then there are events. So creating automated snapshot and snapshot created. Those were the events that took place when the snapshot got created. And there is an automated tag already added, workload type and everything. So for now it's okay. Now the first action that we are going to learn is how to take a snapshot. So that is the first topic, take snapshot. Now come to this page on the snapshots and you already see that there is a snapshot. So the first thing that we want to do is take a snapshot. So click on take a snapshot, select this and click on take a snapshot. And from there you will see preferences. In the preferences, what database instance do we take a snapshot of? We are going to take a snapshot brand new of the existing database. So on this, select the MariaDB instance and give a snapshot name over here like this. Once you have given the name, click on take snapshot. It is as easy as that. You are creating a new manual snapshot. So it is getting created. You can scroll over here and you will see that it is creating. Progress is 0% because it just started. And here is the type where you can see that this is manual and this was automated. This is automated backup. This is a manual snapshot. And the size and everything is the same. So go on and compare. The rest of the details are exactly the same. So come back over here and then you can click on this. You'll be able to see the same kind of details almost exactly matching that we had for the automated backup. You can scroll down and see, come down and you will see that creating manual snapshot. So this just started and is in the creation process. So let it get created. In the meantime, we will move on to the next action, which is how to share a snapshot once it is created. So go ahead. My snapshot 01 was the one that we were creating and it got created. Now select this my snapshot 01 and in the actions you will see all these different actions. And we are going to look at all these three: restore, copy and share. So let's start with share snapshot. Click on share. You will be able to see that where do you want to share? Do you want to make it totally public so that anyone in the world can access this? Anyone having an AWS account can access this. If you want to make that kind of public, you can do it over here. But let's say if you want to make it accessible to certain AWS accounts, a realistic example is you may have dev, test, stage, prod, those kind of accounts. Now let's say that you are doing something in the dev account and now the database is ready and you want to take a snapshot and port it to a different prod account. You can give the account ID of the prod account and click add, and this snapshot will be available to you into your prod. In that way, you do not have to copy all the data into some S3 bucket or take a backup there and restore it and download it. No need of those kind of stuff. Just share the snapshot from here. So that is what you can do. And this is it. Let's move on to the next action, which is the copy snapshot. What is the difference between share and copy? That is the question that will obviously come to your mind. So let's look at that. Select the snapshot first from here, and on the actions you should have copy snapshot. Click on copy snapshot. You will see all the different details. Now here you are copying the snapshot in the same AWS account but to a different region. For example, you have a dev account and your team is federated. Let's say some of that is in US, some is in Europe and federated all over the globe. And now you want to create a database let's say in EU, in Paris. So what you can do is the destination region you can change and you can select like EU Paris. This selection will make it available in Paris, so that now you are creating the new, copying the snapshot in Paris, in that region. You can select a new option group or copy tags. If you want to enable or disable encryption, you can do that as well. And once you click on copy snapshot, that snapshot will get created into that region. So after the snapshot is created, what you should do is change the region from the console, and if you go to RDS in that particular region, you will be able to see the snapshot available to you. So that is the next action. Now moving on to the another action is restore a snapshot. We create snapshots so that whenever we have the need, we can restore from the same. So let's look at what is the restoration process looking like. Go back to the same snapshot. From actions, you will see restore snapshot. Click on that. And here you will see restore database instance. Now when you want to restore the database instance, this is almost similar to creating a brand new database instance. The only difference is it is creating from an existing database. So select all the engine class. I will just scroll through it very fast because we have already seen it into the first 2 chapters of MariaDB. All the same kind of details, whatever you want, you have to provide. One detail that you have to select is what is the new name for the restored instance. I am giving it as my restored instance. So provide that kind of name. Scroll down, you can select the same existing VPC that you already have, subnet group, everything existing, default database options, encryption, logs, maintenance. This is like setting up a brand new database. So all of this is done, and then finally you will have the button restore database instance. Click on that and it will start restoring the instance. And over here you will see that the restored instance that is getting created. Now if you scroll, you will see that it is getting created. Same VPC, almost everything will be the same. Here one thing to be careful of is that if you are not careful enough about which instance size you are selecting, because I went through it pretty fast, I did not care to select which instance size. So earlier I created a t2.micro, but here I ended up creating an m4.extra large. So that is one thing to take care of. That is the lesson, because in a hurry when we are trying to restore, we often forget these kind of things like networking details or instance sizes. So be careful of that, because you will be provided with default options. So once it is getting created, in some time you will see it in an available state. So in this way, we restored the instance also, and we completed 4 different actions: creating a snapshot, copying, sharing, and restoring the snapshot. And here is the summary of what we studied. These are the 4 actions that we studied on the snapshot in this chapter. So I hope now you understand how backups are being taken, how to share a snapshot with a different account or totally make it public, how to copy it in a different region within your account, or how to restore that snapshot and create a new database out of the backup database. So this is how you can do it. With this, we will end this chapter over here, and we will focus on the restoration and more details in the next chapter. Hello guys, welcome back. Now in this chapter, we are going to look at some instance related actions. These are very easy actions but very important ones, so that you know that these actions are available. For example, stopping an instance or deleting an instance or restoring an instance. So we will look at some of these menu options at the instance level, and we will quickly go through these. So the first is stop instance. How to stop an instance. So I need you to go to the databases, select the restored instance that we created in the last chapter, open the actions menu, and you will see the stop instance. So click on stop like this, and you will get this pop-up wizard that, are you really sure you want to stop this? Now you can say yes or no for the create snapshot. Do you really want to create the snapshot? We do not want to create the snapshot, and by default it's no. Now one important information to keep in mind is, if you stop an instance, you can stop it for up to 7 days. If you do not manually start your database instance after 7 days, then it will automatically be started. So if you just stop an instance and forget it like for a month, after 7 days it will again get started and you will incur costs. So keep these in mind. For now, we do not want to really stop it because we know what is going to happen. So for now, cancel it. Let's move on to the next action. Reboot instance. So now let's see what it does. The same thing, go on the action menu, click on the reboot menu item, click there, and you will see it is asking you, do you want to reboot? Very self-explanatory, very easy. It will reboot the instance. So for now, we do not want to do it. Cancel. Moving on to the next one, restore point in time. Now you may be wondering why I did not cover it into the backup and snapshots chapter and why here. This is going to create a new instance and it's an instance layer action. So I'm trying to cover here. And the most basic thing, when you select an instance, you will see it in the actions menu. So that way you can remember it. So let's see. Select this again from the action menu. You will see restore to point in time. Click on that and then you will see what restore time, the latest restorable time or you want a custom time, both are possible. For now we will go with the latest one. After that, go down and you will see instance specification, the same kind of thing you specified while creating a new database. So MariaDB Community Edition, the settings if you want to give an identifier, the network, security and all those things. Settings, network, security and all those things. We do not want to go into the depth of all those things again and again because there are like 5 more databases that we are going to cover and we are going to see this a lot of times. Plus, I am sure you would have practiced it a lot already. So, assuming that if you specify all these different settings like we did earlier, it will restore to the point in time and create a new database. For now, we do not want to go more than that into this topic. So let's move on to the next action. The next action is pretty easy, delete the instance. So from the actions menu, click on delete and it will ask you, do you want to create snapshots or retain automated backups? We do not want to. We do not want to incur unnecessary cost. So remove these checkboxes and then it will say you should acknowledge it, write delete me. Do the same and then the delete button would get activated. Click on this delete and it will start deleting this restored instance. And in some time you will see it successfully deleted the instance. So pretty easy. Moving on to the next but very important action, restore from S3. This one. So when you go over here, you see this button, restore from S3. It's a very important topic actually and a use case. So and we are going to cover it into much more depth actually in SQL Server. So because this is one of the commercial database and we will learn there that how do we import backups into S3 and import that into the actual database hosted on cloud and again take it out by exporting. That is a broad topic, we are going to cover it. But still for now, for the sake of completeness, let's go and look what kind of options it provides. So click on this restore from S3. You will see that all these options are available, but 4 of them are disabled. The reason is Aurora and MySQL are based on the MySQL engine and MariaDB is also kind of a side fork of MySQL only. In fact, if you go to the MariaDB page, you will see a lot of feature comparison with MySQL where it tries to say that these many are compatible, this many are not compatible, and it will be compatible, etc. So here it allows you to select any one of the engines. You can select Aurora or MySQL. So let's select MySQL and then it will give you 4 steps. Firstly, you are selecting an engine. Then you are specifying the source backup details, means where in S3 is your file available, the backup file. Then you specify the database details, the database that you want to create like ID, passwords and those sort of things. And finally configure the advanced settings. And by now you will know that advanced settings means the VPC and the network related settings. And then the database will get created. So select this, scroll down and click on next. Once you click next, you will see that source database specifications are being asked. Depending on the engine that you select, you can also select the version. So and then the S3 bucket where the backup path is lying. you can select the bucket, give a prefix, and then finally the IAM role and next set of details. We do not want to go into more depth here because we have an entire full depth dedicated chapter on this for in the SQL Server section where we will cover this. For now, it is enough to understand that you can get backups using the restore from S3, and using that backup you can restore a brand new database over here on the cloud. So to summarize what we covered so far, here are the actions. We learned how to stop an instance, but after 7 days it will be up again if you do not do it manually. Reboot an instance, restore to point in time, whether the latest time or a custom time that you specify. Delete an instance, we already deleted the restored instance, and then we learned what is restore from S3. So with this, we will end this chapter over here. Try to understand what all we have covered in the previous 2 chapters, all the actions, and once you are ready, please join me in the next chapter. Hello guys, welcome back. Now it's time to wrap up MariaDB and the resources that we created for it. So this is going to be a very short chapter. We are going to quickly wind up and delete all the resources that we created because we are done with MariaDB in this section now. So open the instance, my MariaDB instance. You should have only that instance. Here is a delete button. Click on delete. I just want to show that you can delete it from here as well. So once you click on delete, you will see this prompt asking you whether you really want to delete it and whether you want to create a snapshot. Say no. So change the settings over here, no, and it will ask you for an acknowledgement that you want to delete it. So click on this and write delete me like this, and you will get a delete option. It's pretty straightforward. Click on delete and your instance will start deleting. Now we also created some of the other resources like subnet groups and etc. So we will delete those as well. For now, let's wait for the instance to get deleted, and in a moment this instance should get deleted. It may take some time to disappear from here. It's a recorded session, so I was able to show it to you in a moment. After that, click on the subnet groups and you will see the subnet groups created. As you can see, it was created from RDS Management Console. So select all of these by clicking here and then click on delete to delete them. It will ask you, do you want to delete these subnet groups? Say delete and it will get deleted. Now moving on to parameter groups. In the parameter groups, you will find different parameter groups based on what you have created earlier. I have also created Aurora and other things, so I have all this. But select MariaDB and click on delete from this parameter group actions. And when you try to delete, it will ask you that do you want to delete? Click on delete and you will get an error because it's a default parameter group. Default means this is the only parameter group available if no other are available, and by default it will be applied. So you cannot delete a default parameter group. Also neither you can modify it generally. So for now cancel it. We do not want to delete it. That's okay. The one last thing that is pending is the option group and the VPC. So option group, let it be there. We will jump on to the VPC. But before that, let's look at the events because it will give us a summary of what all we have done so far. So when you go to the events, you will see that first, because when you create a new instance, it gets restarted, then it gets created. Then it backs up, it creates automated snapshot and all those stuff. And finally, we decided to delete it. So it was shut down and then instance got deleted. So this kind of shows life cycle. And here you can see that what was the type, instances and snapshots. So this is the overall life cycle from the point it got created, from the point it got deleted. So this was all about the events. Now let's jump on to VPCs. I need you to click on the VPC dashboard and come to the VPC console where you can see your VPCs. When you come to this particular area, if you have different VPCs already, for example, you had some custom VPCs, you have default VPCs, now you are creating a new one, you will see a mix of VPCs. To avoid this confusion and to make it plainly simple, because in all the upcoming database chapters, at the end of the section, we will just delete the VPC. So this ensures that everything that you created has got deleted. So there is no cost, there is nothing idle pending that you may continue getting charged for. So for that, we are going to use Oregon. I am going to use Oregon. You can choose any region that you like. or if you want to continue with other additional VPCs, that is fine too. I'm just trying to make it easier and convenient for the students so that they do not get confused. So here what I have done is selected this VPC from the actions, delete VPC. Select this delete VPC. As usual, it will prompt you that you want to delete. So say yes, you want to delete the VPC. Click on yes, delete. So finally you are done with deleting all the resources that we created for MariaDB. And here we also wind up the MariaDB section. So thank you guys for listening to me patiently. As we go forward in the upcoming chapters, some of the things might get repeated, like deleting a VPC or some of the steps related to the database. But I promise you, in every database section, you will find something new. It's not a recurring same set of chapters, just a different engine, but all the things same. In every database section, you will learn something new. I can guarantee it. So stay tuned. And once you are ready, once you are okay and have digested the MariaDB chapter, please join me in the next chapter. Hello guys, welcome back. In this chapter we are going to cover how to create an Oracle database instance on RDS. Now I know that we have already tried it earlier on MariaDB and SQL Server. So what is new in this? This section is almost the same as SQL Server with very subtle differences, but I need to have this chapter series of Oracle for the Oracle guys who are seasoned on Oracle, or those who may have interest in Oracle and they may have chosen to skip the SQL Server section or the MariaDB section. So I do not want them to be left out. I would highly encourage that if you have not gone through MariaDB section, please go through that, because the basics are covered in great detail. This is for learning the basics there with a simpler database comparatively. After that, you can go to a database of choice like SQL Server, Oracle, MySQL or Aurora, wherever you want to. I am covering different topics in each database to keep the mix interesting. But for the purpose of completeness, we are going through the Oracle section. Those who have already gone through SQL Server section, or those who are not interested in Oracle, please skip the entire Oracle section, all the 3 chapters. So let's get started, guys. We will be going pretty fast the way we went with SQL Server, assuming that you have the basics. So open the RDS console as you can see on my screen. Now go down and click on Create Database. Once you click over there, you will see all the different database options. Obviously, you need to select Oracle. Click over here, you will see all the different editions available. In this, like we did in SQL Server, 4 editions, we are selecting the biggest one. You do not need to really carry out this lab because it may cost, but if you are interested, carry on all the steps with me. And still, if you choose that you want to carry out all the steps but not incur cost, just do not press the Create Database button at the end, so that you do not get charged for all the database instance and all the resources creation. So we are over here selecting the Oracle Enterprise Edition so that all features are visible for configuration. Scroll down, click on Next. Which use case? Of course, development, because we are just trying out an exercise. Dev. Click on Next. Now it's the time to select the license model. In SQL Server, it was license included. Here it is bring your own license. So you may create an instance, but you have to have a license of your own. They are not responsible to provide you a license. So if you open this, you will see that there is only one license option available. So which is fine for now. The latest version is selected. Scroll down and you will see that the database instance class, AZ deployment, etc. You can select the multi-AZ if you want. For now, we will go and just select it, and as you can see, the price doubles because we have selected now the multi-AZ, which is okay for now. Scroll down and I deselected it because I do not want to put a double cost. So as you can see, the price is half here. In the settings, provide whatever database instance name, user ID and passwords that you want to. It's pretty simple. I gave my Oracle DB as the database instance name, AWS user and password. Scroll down and click on Next. It's the time for advanced settings, means the network. We will stick to the default network creation, like create a new VPC subnet group and all that stuff. But we want public accessibility because we will install an editor on the local machine, and using that we want to connect to the Oracle instance that we are setting up on RDS. So select yes. and scroll down. Over here, provide the database options. I have already provided Oracle. Port number is 1521 and these are the default options. So let it be as it is. Just provide the database name Oracle or whatever you want. And here there is an encryption option if you want to. Do that and scroll down. We will go with all the default options: backup, monitoring, log, exports. We are really not interested in changing all these settings. All we want to do is set up an instance. So scroll down and you can see that we are almost at the creation step. If you do not want to incur cost, do not press this button. Then if you press this button, it will start creating your instance, and whatever minutely, even if you delete the database instantly, you will still get charged a little, whatever it is, depending upon how long you keep the instance live. This is Enterprise Edition. If you have kept multi-AZ, it will cost even more. So be careful. I am doing a create database, and here the database instance is being created. You can click on this to learn about connecting to your database instance, because from there we will get a link to install the client or the editor using which we will connect to the Oracle database instance. So with this, we will wind up this chapter over here. It was pretty simple, the same 4 steps. We provided configuration settings, network, instance name, password and all those details, and our instance is getting created. Now in the next chapter, we will learn how to connect to that Oracle instance that will get created. So with this, we wind up this chapter over here, guys. Once your database gets created, you can join me in the next chapter. Hello guys, welcome back. In this chapter, we are going to learn how to connect to the Oracle RDS instance that we created on AWS. So if you had opened that link where it says learn how to connect to your Oracle database instance, it will open up that page, and this is the page. As you can read over here, it says that you can use Oracle SQL Developer or SQL Plus to connect to it, or any other editors that may be supporting a connection to Oracle on RDS. We are going to use Oracle SQL Developer. For now, let's go back and let's see the database creation process. So come back to here and open the view database instance details. Now as you can see, the status will be creating initially. Scroll down. Let's just take a look through how all these different sections look while it is getting created. As usual, these are all the metrics. The connection endpoint is not available yet because it is getting created. It is publicly accessible. Rest of the sections, as you scroll down, the configuration and all that summary is the same like we saw in the rest of the databases. Scroll down, you will see replication, CloudWatch alarms. All these different sections are exactly the same for all the 6 databases out there. So scroll down and you will see more. Now if you go back up on the instances, you will see that it is still creating, and when you open it in some time, it is now if you click on instances, you will see that it is still creating. Scroll here and you will be able to see the rest of the configuration. Open this and you will be able to see that it's backing up as usual. We have seen in the rest of the databases also, and in some time it will become available. Because it is backing up, as you can see, the endpoint is now created. Copy this endpoint and keep it handy, because you will need this to connect to the actual database instance. This is the actual endpoint to connect, and you will have to paste this into the editor. So keep it handy. In some time, the instance would get available. So now our instance has got created. 0 connections. I will show you how the connection will change to 1. So this is 0 over here. Now let's go back, and over here if you scroll down, you will see the download link for Oracle SQL Developers downloads page. Go over there and you will see this page that you want to download it and install it. You can accept the license agreement if you want to. Click over here and it will say fine, and you can download the software for whatever OS and version that you have. This requires a sign up. So try to download this. I am going to download the Windows version, and then it will ask you to sign up. If you want to sign up, if you are okay with this, then you can. Or you can use a different editor which is available free of cost without a sign up. Whatever suits you. So I signed up on this, I downloaded it and I installed it. After I installed it, it looks like this. This is the Oracle SQL Developer. On this page, now when you click on the plus button, you can have your connections. So click over there and it will ask you to provide the details. connection name, username, password, and the host name, which should be your endpoint, and the default port. SID it should be Oracle because we gave that ORCL. Fill up the details like this. I already did it over here, as you can see, and click on connect. And you should get connected to the RDS Oracle connection. I gave this name, but this is the instance on cloud. So once you are connected, you can operate anything on it. Just to give you a feeling that we are able to operate on it, let's go and create a table. So select on this table over here and click on the plus button, and you will see it gives you a create table pop-up. Provide whatever name that you want. Schema is AWS user by default because that is the one with which we have created the Oracle instance. Provide some table name, some column name, like I have created column 1 and table 1, just some random tables. Once you do that, click on OK, and as you can see, your table and column got created. So now, because we have created a connection to the Oracle instance, there is one connection that is live, and we know that. If you go back to the metrics, now you will see over here, it spiked to one connection. So these metrics are working. It is showing you that someone is connected to your Oracle instance. Even if you go out and look over here, you will see that in the current activity, there is one connections. So in this way, we saw how we can download the Oracle SQL developer and make a connection to the Oracle instance that we have created. This is pretty basic, but I am sure Oracle guys will like this because they might be interested in that how they are downloading it. I am sure they would know how to download Oracle SQL developer, but connecting to it, getting a feeling of how it gets connected, then some activities getting shown on the dashboard, that is cool for the Oracle guys, I am sure. So with this guys, we will wind up the chapter over here, and once you are ready guys, in the next chapter we are going to wrap up the Oracle instance. We are not going to go into any more depth on this in Oracle. We have already covered some concepts in SQL and some in MariaDB. We are going to cover more in Postgres and MySQL and Aurora. So for now, let's wind this up, and once you are ready, please join me in the next chapter. Hello guys, welcome back. It's time to delete the Oracle instance and the VPC associated with it. And in this chapter, we are going to do the same very quickly. So on this instances page, select the Oracle database instance that you have created. On the instance actions, click on this and you will see delete. Click on delete. It will ask you for a snapshot, yes or no. We do not want any snapshots. Select no from here and then check this box of acknowledgement, type delete me. Once you are over here, click on delete and the instance will be deleted. So it will show deleting status. In a moment, it should go away. After this is done, now it's time to firstly look at the events before we go to the VPC. So click on events and see the life cycle. Exactly like the previous ones, instance was created, backed up, snapshot created, instance then shut down and deleted because we initiated a delete. So these are the events. After that, let's go to the VPC dashboard. Open VPC dashboard. Over here, you will see a single VPC. Open that VPC. Select the VPC from action menu. You need to have delete VPC. Select on delete VPC and then say yes so that the VPC gets deleted. Click yes, delete, and in a moment the VPC is deleted and your environment is clean. So with this, we are done with the Oracle section, and we also deleted and wrapped up all the resources. Once you are ready guys, join me now in the next section where we are going to start with a new database. Hello guys, welcome back. In this chapter, we are going to learn how to create a PostgreSQL instance on RDS. We are going to learn how to connect to it, and one thing that we will learn new in the PostgreSQL set of chapters is how to create a read replica and how to promote the same. So that we have not covered with previous database. So that is something new you will find interesting in the PostgreSQL set of chapters. And I am sure those who are PostgreSQL professionals will thoroughly enjoy it. So let's get started with it. So firstly, scroll down and click on create database. Once you click on that, you will find this, that here are a selection of 6 databases. We have seen these screens multiple times, so I will not go into more details. Select PostgreSQL. You will see this kind of 4 steps. Scroll down, click next. Here we need to select use cases. Let's use dev. Select next. Over here, PostgreSQL license, database engine version latest. Here you can see what all instances. I will select an M4 dot extra large. Scroll down. Now here we do not need a multi-easy deployment. All the defaults, look at the cost, come down. Here we need to provide database settings, fill it up, Postgres instance, that is the name I am giving to my database instance, master username AWS user, all the password, confirm password, and then click next. Here we have to configure advanced settings. I am going with all the default options, creating a brand new VPC and let it figure out the network. Public accessibility is required because if we do not say yes, we won't be able to connect to it from our local machine. So I'm going to say yes. Scroll down. Here you will have database options like what database name you want to give. Port number is 5432. When you start using Redshift, you will realize that it uses the same port number. So if you have a PostgreSQL instance and a Redshift instance, then you may want to check that both are listening on port 5432 because that is default. And Redshift basically has Postgres as the backend engine. Redshift is actually built on Postgres. So whenever you are creating a Postgres instance as well as a Redshift instance, make sure it is on which VPC and ports, because it can happen in some cases that they are listening to the same port. So provide that database name. My personal DB is the name I chose to give. Scroll down. Backups, monitoring, all defaults. Performance Insights is also available for Postgres. So keep that in mind. Aurora, Oracle, MySQL and Postgres. It is available for all of these. So we have chosen to have enable performance insights. Retention period default 7 days. We do not want for 2 years and all. We can encrypt with the master key. Scroll down and then we will create the database. Click on create database and we are on our way to get our first Postgres database. And in a moment you will see this kind of screen that the instance is being created. So with this, our first instance has got created. We can click on learn about connecting to your database instance. From there we are going to get the utility installed which connects to PostgreSQL instance. For now, let it be, and now open this database instance details. You will see that it is creating. In some time, you will see that it is backing up. If you scroll down and see, there is a endpoint created. This is the endpoint that we will use to connect to the PostgreSQL instance. So copy this and keep it handy. We saw that the status was backing up. So if you scroll down more, you will see that snapshot is getting created, which is fine. Scroll up and in some time the Postgres instance will be available. So with this, we have created the PostgreSQL instance and which is now available to connect. So this was a very quick chapter on how we can create a PostgreSQL instance. One thing to keep in mind is the port. Whenever you create Postgres and a Redshift instance, make sure which port they are listening to. Try to make sure they are both not listening to 5432 in the same network. So this is all about creating the instance. Let's wind up this chapter over here. And once you are ready, please join me in the next chapter where we are going to connect to this instance from our local machine. Hello guys, welcome back. In this chapter, we are going to connect to PostgreSQL instance. Go to the tab which we opened in the last chapter. It should have a page like this. Here is the link connecting to a DB instance running the PostgreSQL database engine. So click on this. Once you click on this, it should open a page like this. And here you can see that it is saying that using the PgAdmin utility, you can connect to your PostgreSQL instance. It's not the only one, but probably a recommended one. So click on this URL and it will take you to PgAdmin. So PgAdmin is one of the popular utilities to connect to PostgreSQL. Now what you can do is go on download and go there, and here are different options available based on what you want to download for. So for my case, it is Windows. So I will go ahead and download this. You can click on whatever OS that you need or whatever requirements that you have to install it on your machine and download it and install it. And once you do so, it will look like this. I have already installed it. As you can see, the PgAdmin 4 utility is here. To open it on your browser, you should use this kind of URL 127.0.0.1, that is kind of localhost, and this is the port and /browser. Once you install it on your machine, you should also get a shortcut, and you click on that, it will open up. So over here, what we can do is right click over here, and what you will get a menu like this, create and server. So click on this and you will see this kind of pop-up. Provide the name for your server. This is a connection name, by the way. This is not the server name. So provide the name that you may like. I gave the name MyRDS instance. And go to connection. When you come to connection, it will ask you for details. By default, it already has the port 5432. These are the default main database and username. Fill it up with the endpoint like this. This endpoint will be available on your console in the instance that you have created. 5432, the port remains the same. The database instance name we have given Postgres, username AWS user, and your password. So fill it up like this. Once you fill it up, you can click on save, and saving will create the connection. So click on this and you can see that this has got created. Expand this and you will see that it has connected to your database MyPersonalDB, and all the different values are here. If you wait, then you will also see some graphs and data if you do some activity, and you will get a confirmation also that database connected. So this was a very easy, small, quick chapter on how you can use PgAdmin utility installed on your machine, and using the endpoint which we have made publicly accessible, you can connect to it from your local machine, connect to the PostgreSQL instance on RDS. Let's wind up over here, and in the next chapter we are going to create a read replica. So once you are ready guys, please join me in the next chapter. Hello guys, welcome back. In this chapter we are going to create a read replica. It is not something new, we have already done it earlier, but in this let's create it quickly because the intention is we want to see how to promote a read replica. So for that, firstly we need to create one. So let's do that. Come back on the RDS console. On the instances, you should be able to see the Postgres instance that we created. Click over here and then it would get selected. Go to instance actions, and from instance actions select create read replica. Click over here. You will get a wizard. You have seen this earlier also. So destination region remains the same, all the default options, but we want to make it publicly accessible. So select this yes. Scroll down, encryption, all of these remains default, no need to change because we are not going to connect and do activity, we just want to see how to promote it. So which is okay. Scroll down. Here we are supposed to give an instance identifier. Source is the Postgres instance, but we need to give a new name. So let's give a name that is relevant. I am giving it a name read replica 01 just so that it becomes clear that it's a replica. Database port remains same. Monitoring, we are not interested right now. Scroll down. Everything remains the same. Performance insights, we can enable. There is no impact actually. And now click on create read replica. So what will happen is once you create, it will start modifying it. And the read replica creation has started. The reason it is being modified is because it is trying to be the master and this will be the reader. So it is getting modified. After some time you will see that it is available. This will keep on creating, and in some time read replica also will be modifying because it is rebooting, creating snapshots, and in some time it will become available. Now both the instances are available back in shape. Click on read replica just to be sure this is available. If you scroll down, you can see that it is already replicating. So the read replica now is in place, replicating with the Postgres instance. In the next chapter, we are going to learn how to promote it. Promoting makes it independent and it becomes a totally different instance. Earlier we understood what is the reason to create a read replica and what are the benefits and limitations. And then we also understood how to promote it so that at certain time when the replica is mature or the purpose of the replica is to be used independently, we can promote it. So let's wind this chapter up guys, and once you have created the read replica, And once you are ready, please join me in the next chapter. Hello guys, welcome back. In this chapter, we are going to promote a read replica and understand the process that what happens when we promote a read replica. So select the read replica over here and click on the instance actions. When you do so, you will be given an option like promote read replica. So select that and it will bring up a screen like this. It is asking you whether you want to take backup, retain it for how long, and whether do you have a preference when to take backups. So for now we are going to go with defaults. So go ahead and click on continue. And then you will see something like, are you sure you want to promote this read replica? Read this portion where it says that note that the promotion process takes a few minutes. Firstly, it takes some time, and when you promote a read replica, replication is stopped and the read replica is rebooted as a part of the promotion. In addition, the promotion process is irreversible and you cannot restart the replication with the promoted DB instance as a replication target. So this text is very self-relevant here. The replication is stopped and a backup is taken, it is rebooted, and then this replica instance becomes an independent database instance. So let's see what happens. Let's click on promote read replica. When you do so, in some time you will see that it is modifying. So let's see what's happening. Click on this and go inside and you will see that replication is still happening, but in some time what you will see is the replication has gone, that entry has gone, that it was replicating with the Postgres instance that is no longer available. Go up and you will see that it is rebooting. Click on the events and you will see that promote read replica to a standalone database instance. This is the action we asked for. Instance was shut down, some parameters were changed, and then it will be restarted. Now when it is being restarted, it is also backing up. If you click on instance, in some time you will see it is backing up. And if you go inside and check the snapshot section, you will see that over here in the snapshots, a backup of this is getting created. And in some time when you go up and see, it will be available. Now this has become a totally independent database instance. There is no replication happening and we have promoted a read replica. So whenever you have that kind of scenario where you need to detach replication and make that as an independent instance for whatever business scenarios you may have, and we learned about those kind of business scenarios in earlier chapters, in that case you can promote a read replica. The process is very simple. One thing to be kept in mind is the replication once stopped, it cannot be set up the same way. You may have to create a new read replica out of the main instance. So that is one thing that you should keep in mind. With this, we will wind up the chapter over here. That was the only new thing that you will learn over here in this chapter. The two things that we learned new is using the PgAdmin utility, port 5432, and how to promote a read replica. The rest we have been learning in the previous chapters. So let's wind this chapter off over here, and in the next section we will clean up the resources that we have created so far, and that will be the end of the Postgres section. So once you are ready guys, please join me in the next chapter. Hello guys, welcome back. We have done it number of times and we know the drill what has to be done here guys. So let's quickly remove both the instances as well as delete the VPC. So firstly, select the instance like this and go to the instance actions and you will have a delete option. Pretty simple. Click on delete. It will ask you for snapshot or name. We do not want snapshot. Select no. Acknowledge it. Type delete me so that this button gets active, and then click on delete. So it will start deleting. In the meantime, select the other instance. Do the same stuff. Instance actions delete. It will ask you for the name. Change the stuff. Say no. Acknowledge, delete me, click on delete. So now this is also deleting, and the previous one has gone, and in some time you should see that both have gone. Now come to the VPC dashboard. Once you are on the VPC dashboard, you will be able to see there is one VPC. Click on the VPC. You will have an actions menu. From that you have delete VPC. Select delete VPC and it will ask you for a prompt. Say yes, delete the VPC. And it will delete the rest of the stuff. So with this we have deleted all the resources that got created in the background when we created PostgreSQL instance. And now we are done with PostgreSQL. I know some things were repetitive and it was a short chapter, but at least we learned some key small points. And for those who may have jumped out from different databases, for example, you started with MariaDB but did not attend SQL, or for example, you started with MariaDB and you may have skipped Oracle or SQL and you jumped on directly over here. So at least that way, for the purpose of completeness, I had to include this chapter, though it may sound a little repetitive. So will not take more of your time, and thank you for being patient, guys. Let's jump on to Aurora. This is the last database in the series and a very important one. So I will see you now in the next chapter. Hello guys, welcome back. Let's get started with some basic FAQs before we start and jump into the labs. Generally I cover FAQs at last, but we have like 6 engines, almost 9 sections. So I will be dwelling 100% into the labs in all those sections. So no theory at all. This is the last chapter on RDS theory that we are covering. So I wanted to cover some very high level basic FAQs and then we will learn everything through labs. So let's get started. Which relational database engines does AWS RDS support? Aurora, MySQL, MariaDB, Oracle, SQL Server and PostgreSQL, 6 of them. How many databases or schemas can I run within a database instance? It is different for most of them. So this is one thing that you need to keep in mind, is that different database engines support different types of features and they have different types of limitations. So whenever you have a question, you should always go to a particular engine, find the AWS documentation and look at that limits for a given version, because all this database engine also has different versions. Can I test my database instance with a new version before upgrading? Yes, you can. Billing. How will I charge and bill for my use of Amazon RDS? As you can see, we learned all of this during the pricing section. Database instance hours, for example, 720 for full month. Storage, how much is the size of the instance. IO request per month, how many are input output requests typically for Aurora only, and we saw that. Provisioned IOPS, if you have procured more capacity, if you have got that kind of IOPS reserved for instances, and for that also. Backup storage, we saw this as well, that if we add backups, this has a marginal impact as well. And data transfer, so what is the data transfer in and out, within a region or across regions. How do I import data into RDS? There are different ways for different engines, like for example data pump, import export for SQL Loader for Oracle, import export wizard, bulk copy program for SQL, lot of different options, and there is a guide where you can go and look at it. What defines billable RDS instance hours? Instance hours are billed for each hour your database instance is running and is in an available state. If you no longer wish to be charged for instance, you must stop or delete it. And keep in mind that you can stop an instance only for 7 days at max, then again it will start. Partial database instance hours consumed are billed as full hours. So let's say if you use the instance for 1.5 hours, you will still be charged for 2 hours. How will I be billed for stop database instance? Answer is you will not be billed for stop database instance, but you have any provisioned IOPS or you are using any backups or those extra features, you will be charged for that. What is a reserved instance? Reserved instance gives you the option to reserve a database instance for 1 or 3 year term, and we saw how the different type of cost like no upfront, partial upfront or all upfront gives you that benefit of cost. Reserved instances include a capacity reservation. Reserved instances are purchased for a region, then for an AZ. So let's say that if you reserve a particular database instance in Northern Virginia, you can create it in US East 1A, 1B or 1C. It is not specific for an AZ. RIs are not specific to AZ, they are not capacity reservations. That means if a capacity is limited in one AZ, reservation can still be purchased in a region and the discount will apply to the matching usage. Will my database instance remain available during scaling? The storage capacity allocated to your DB can be increased while maintaining DB instance availability. So the answer is that yes, it will remain available. But let's say if you decide to scale the compute resources available to your database instance up or down, your database will be temporarily available while the DB instance class is modified. So for example, let's say that you go from an R4 to an M2. That kind of change, if you make it the instance type level, then it may become unavailable temporarily because it will go to a different instance type, may do a reboot, and then it will become available. What is RDS General Purpose SSD? General Purpose SSD is suitable for broad range of database workloads, have moderate I/O requirements, with baseline of 3 IOPS per GB and ability to burst up to 3000 IOPS. This storage option provides predictable performance. That's what it says. By default, you get 3 IOPS per GB as a baseline. What is RDS provisioned IOPS SSD storage? So here, IOPS SSD storage is an SSD backed storage option designed to deliver fast and all that performance. With RDS IOPS SSD storage, you specify an IOPS rate, input output per second. How many transactions do you want to do per second? That kind of rate when creating a database instance. And RDS provisions that IOPS rate for the lifetime of the database instance. And you will also pay the charges for the lifetime of the database instance for that extra reserved provisioned IOPS given to your database instance. This is a guaranteed capacity of input output per second provided to your database instance. It is optimized for IO intensive transactional workloads. What happens to my backups and database snapshots if I delete my database instance? So upon deletion, you can use the database snapshot to restore the deleted database instance at a later date. So Amazon RDS retains the final user created DB snapshot along with all other manually created snapshots after the DB is deleted, and this is optional. When you delete a database instance, it will ask you whether you want to create a final snapshot. If you say yes, then it will get created, else there will be no snapshots available. All the automated backups are deleted when the database instance is deleted. Only manually created snapshots will survive. Can I encrypt connections between my application and the database instance using SSL? Yes, so there is an option called force_SSL, and if you set that parameter to on, all the connections between your client and the database instance on RDS can be encrypted using SSL. One thing to keep in mind is, while it offers security benefits, it's a compute intensive operation and it will increase the latency of your database connection. What are database parameter groups? Parameter groups and option groups are two features available in every RDS. So it's a set of parameters that you can change. Read this. Database parameter group acts as a container for engine configuration values that can be applied to one or more database instance. So a number of database instances can share the same configuration that you apply to a parameter group. If you create instance without specifying DB parameter group, a default database parameter group is used. This contains engine defaults. You cannot change this one, but if you want to customize this parameter group, you can create a new database parameter group. How to monitor the configuration of RDS resources? There is a service in AWS called AWS Config. So if you enable it, all the changes that you do across all the resources, you can monitor through that. And also you can set up alarms, and those alarms can be tied to SNS. So whenever anything changes, you get that kind of alarms. These alarms can also be made on CloudWatch metrics, so that you create a CloudWatch alarm and anything changes. Let's say your disk utilization is 90%, you want to get an alarm. You can set up that kind of CloudWatch alarm with SNS and you will get that kind of notifications. Which versions of database engine support read replicas? Aurora supports RDS for MySQL, PostgreSQL and MariaDB. One thing to see is SQL Server and Oracle does not support. So these kind of differences will come. There are many such questions that you will get. For example, what this database supports or what the engine supports. You should always go to the documentation and look at a particular version of the database, particular edition or license, and see what limits are there on RDS, because there can be certain features of a particular database engine which will not work on RDS. So always refer to the documentation. That will be my suggestion. With this, guys, we will wind up the FAQs. All these FAQs are from the actual AWS FAQ documentation. I just handpicked some of them so that I can bring out that perspective. I suggest going through all those FAQs to know more about RDS. With this, guys, we will wind up this chapter, and once you are ready, please see me in the labs. Hello guys, welcome back. Firstly, congratulations for making it through. I am sure that we went through an express speed. Some of the things were new At some places, you may have struggled a bit here and there because it is new for you, but I am sure that you would have enjoyed this course. Now, to summarize, this is what we were tasked to cover. I would just like you to go through this list. Maybe even you can pause the video and go through this list and just tally, did we cover all this or not? And in case if you have any questions, feel free to send me a message or ask in the Q&A forum. I am sure that you would agree that we covered all of these items one by one throughout the course. And I believe this knowledge is enough to at least get you started, start working on this and explore more and more of RDS. Next steps. So you would be thinking that what are the next steps? Is this 100% of RDS? Are you at an expert level? No, by no means. You are at an intermediate stage. To move on to the next level, these are the advanced features that you may want to consider to learn. I actually teach all this in my AWS Data Architect Bootcamp course. So from that, I have this list already available, which I am sharing with you. So these are the different topics you can consider to learn. You will find a lot of AWS documentation. You can go and try out from there. With the basic AWS RDS skills that you have acquired in this course, you can give an attempt to all these topics yourself and try it out. In case if you need help, you can always enroll in my course AWS Data Architect Bootcamp, where all this and a lot more stuff is being taught. So with this, guys, I hope you understand what we have covered and what you may want to cover next to expand your skills on AWS RDS. So I wish you all the best, guys, and I hope you can make the best use of your newly acquired skill. So finally, a big thank you, and I hope to see you in one of my other classes.